The size of particles in flow cytometry determines several things. First, can you see them? Second, the size may be important when it comes to the volume and surface area we're talking about. This quick demonstration will give you a perspective on what a flow cytometer can do with different size particles. Imagine this is a lymphocyte. It's going to be about 6 to 8 microns in diameter. Beside it, we have a 1 micron object. Perhaps it's a bead or a bacteria like Staph aureus. Now let's see what a 5 micron bead might look like compared with a lymphocyte. Now if we were to place a 100 nanometer, that's 1/10 of a micron bead, on the screen, it would be hard to see. So here are 100 of these small beads. If you keep this in mind, it might give you a perspective on what a flow cytometer can and cannot see. The bottom line is that most flow cytometers will not be able to see these 100 nanometer particles with light scatter. It's pretty much in their noise region. So what have we learned about particles and size in flow cytometry? First, you know the size of a lymphocyte and you know the relative size of a bacteria. By the way, the surface area of a lymphocyte is about 500 times that of Staph aureus. Also, you can see that a 100 nanometer bead is really tiny, and it's 5 times larger than most Q dots. In fact, a Q dot has about 5,000 times smaller surface area than a lymphocyte, and a virus is even smaller than that. So don't sit around waiting to measure a virus by light scatter on a flow cytometer. It's actually smaller than the wavelength of light, so you know you can't resolve it.